sorry about last week. I have to accompany with the UTA president, so we do not have class. I will make a very brief review regarding to the first class. We discussed about the basic concept about the basic concept of the statistics. There are some very important concepts you have to understand in the following lectures. In the first class, we introduced the hypothesis. In the statistics, the hypothesis is very important. In hypothesis means we also assume there are some kind of hypothesis, and then based on this hypothesis, we sampling some data, and then based on the observation of this sample data, then we will make a decision if this hypothesis should be accepted or rejected. Right? Usually we will assume the hypothesis. For example, if we want to test if the boy and the girl, their language ability are the same or they have a difference, maybe we will make the hypothesis. We assume the one means the boy, the two means the girl. We assume the boy and girl, their language ability are the same. Then we conduct a test, and then after the test, we sampling. We based on this test result, then we will make a judgment if this hypothesis should be accepted or rejected. If let's say if the average of the mu one, the boy, if his average maybe is 86, and the mu two, if this is the sampling data. If the sampling data we found, okay, the mu one is 86, maybe mu two is 87. If we sampling maybe just 10 students, then will you say they have difference? Because the only difference is 1 point, and then we only sampling just 10 data. So I think we do not have enough evidence to say, okay, this hypothesis is wrong. Maybe it's because the average for the boy and average for the girl is very, very close, right? But if this is the 86 and then another one maybe is 72, oh, wow. Even we have only 10 data, but since this difference is very large, right? So we might have the evidence, enough evidence to say, okay, this hypothesis should be wrong. Then it means his alternative hypothesis will be mu one not equal to mu two. Maybe we should accept this hypothesis. This means we got a significance. The significance means we will reject the original hypothesis. We will accept the alternative hypothesis. Then we say this has the significance. And there are several ways to say if this hypothesis has a significance. First is we can use the p-value. If p is less than 0.05, it means usually we will say, okay, this is we have the significance. Because this p means under this hypothesis, if this situation happens, the chance to this situation, the sampling data, this situation happens, the possibility is less than 0.05. Then we will say we will have enough evidence to say yes, this hypothesis is wrong. They should have the significant. It means the boy and girl, their language ability are different. So this is the easiest way, because most of the software, they will provide you a p-value. So you can base on this p-value to make a judgment if this testing or this hypothesis should be accepted or rejected. Okay. So if p less than 0.05, then we will say this has a significance. This means we will reject the H naught. We should accept his alternative hypothesis. This is one way. Another way we commonly use is the Z number or T number. So we will see for two-tail hypothesis. For two-tail hypothesis, if mu1 the same, all hypotheses are the same. Mu1 is equal to mu2, right? So then, if our sampling data, we transfer our the data, observation data, we transfer it to Z coordinate. Z is the standard normal distribution, right? Then we will see this. If this in the first class we talk about how to use this normal distribution. If this is 0.05 or 0.025, here is 0.025. Then it means here is 0.95. Then this is called accept region, and then this is reject. If our observation Z number, or if based on this hypothesis, if our observe the sampling Z number is in this reject area, this part or this part, then we will say this is accept. If in this region, then we will accept his hypothesis. If our Z number is, this is called critical value, and this Z is usual. If this is 0.05, then this is 0.95. Here is minus 1.96. Right. So approximate. So we will say if this Z number is greater than 1.66 or less than minus 1.96, then we will say it got a sequence. That's another ways we can make a decision if this hypothesis should be accept or reject. Okay. Then we will do the first test. The first test is called the first test is called the independent t-test. The independent t-test is based on this hypothesis. The hypothesis is mu1 minus mu2 is equal to mu naught. But mu naught usually we set it equal to 0. This means the mu1 is equal to mu2. Or you can set for any number. Maybe you can say our hypothesis is the girl, if 1 is girl, 2 is boy. Then if this is 10, it means, okay, if our hypothesis say, okay, the average, the girl's language ability is better than boys' language ability, at least 10 points of some test. Okay, so this may be 10 or any number you can have like a hypothesis. But most of the case, we only said this is equal to 0. Okay, this is our hypothesis for the t-test. Okay, and in the t-test we can find his z number. The z number is use this equation. This is the sampling data, average sampling data of group 1. This is average sampling of group 2. And this mu naught is usually set equal to 0. And this is the variance group 1, variance group 2. This is number of samples for the group 1 and number of samples for group 2. So we can calculate this z number, and then to see if this z is the greater than 1.96 or in this 9 or less than 1.96. If it's in the reject area, then we will say we should reject this hypothesis and accept this one. Accept this one means the mu1 and the mu2 are not equal. Okay, so that is the independent t-test. Another t-test we will use is called the pairwise t-test. The pairwise t-test is different from the independent t-test. Is the for the independent t-test for each data for this each data, this is a different objective, different people. Okay, this is someone, this another one, this another one. So each one for each data is a different people. But for the pairwise data, it's the same data, but we give them two different treatment. Okay, so first one we will use this to test the t-test, and then this is formula. So this is the formula, and then I will write the formula here because sometimes I cannot remember this formula too. Z is equal to so that's to use the Excel to conduct to illustrate the pairwise t-test. I think I already give you this data, right? Okay, this is assumed we will make a survey. The survey is regarding to the pilot, and the pilot we can divide by the pilot has the captain and the first officer. So it means the pilot and the co-pilot. So the pilot is usually is the captain. The co-pilot usually we call it the first officer. And then this is the example. One of my students, the Peebles, his master thesis. He went to investigate if the service quality of the ATC, the air traffic control, the tower, in airport, the air traffic control, they will provide a service to help the pilot landing or departure the aircraft. So he went to investigate if the service certification, the level of certification will be affected by the different pilot. If the pilot and the co-pilot they consider the service quality, the Taoyuan airport have the significant difference. Okay, that's their purpose. He went to test if the pilot and the co-pilot or the captain and first officer, they consider the service level has significant difference. So that's their purpose, right? So their hypothesis will be if the mu1 is pilot, the mu2 is co-pilot, whatever, okay? And then the H1 will be the mu1 is not equal to mu2, right? They will consider the actually, why they do this hypothesis. Actually, usually the H1, this hypothesis is the we expect the result. We hope that we can prove, okay, the mu1 and mu2 gas has second difference. Okay, that's usually our intention. So, but we make this assumption. We first assume the pilot and the co-pilot, they are regarding to the service, the level of certification regarding to the ATC, they are the same. And then we make the survey to see if they have a significance. Okay, so that's the main purpose of this kind of test. And in this kind of test, it means that the X, usually the X respect to y, right? This is the independent variable. This is a dependent variable. In this case, the x here usually is the nominal scale. Okay, I think in the first class we define what's the nominal scale. Nominal scale means this is categorized is a boy or girl, or the different blood type, or different hair color, or different race, different. So this kind of the variable, we cannot make a ranking or say who is the best, who is the worst, right? So that's the x in this case, because the pilot and co-pilot, we cannot say who is the. Of course, the rank, the pilot is the salary maybe is the higher than the co-pilot. That's obvious, but we cannot say, oh, this is better than another one. Just like the blood type or hair color, we cannot say brown color is better than the black colors people, right? So this is the nominal scale, and the y usually is the Alex should be the interval scale or ratio scale. So this is the when we conduct this kind of test, you have to understand. So this is a category 1 or 2 represent two different people. Okay, then we can do the for example, the x1, the one maybe is, okay, we copy this one. One maybe is the pilot, okay, and the 2 maybe is the co-pilot. So this is co-pilot result. Maybe this is a pilot. Okay, maybe this is the pilot and co-pilot, their response respect to the service level of the ATC. Okay, after we got those response after we conduct the survey. Of course, in the independent t-test, the group 1 and group 2, the number of group 1 and group 2 doesn't need to be the same. Okay, it can be, you can sample in the S1, the group 1 maybe 40 sample, the N2 maybe 35, and then, so this N1, N2, it's not necessary to be the same. So that's the independent t-test. After we got this one, then we can calculate their, we need to know what's their average, right? Average, and then variance. So we can use the function, it's very easy. Okay. The average would be, just have average. So that's the average 1 and average 2. So according to this one, the average of the pilot, their satisfaction level is 2.89, and the co-pilot, the service level is 3.29. It seems they have the difference, but if this difference will be large enough to prove to reject this assumption, so that's we need to check his z number. If this z number is in the reject area, reject region. And then we also need to calculate their variance. How to calculate average and the variance, you should know the formula. I think in the first class, we already demonstrated how to use the basis concept to calculate the average and the variance. So this, but right now, we set the time. So I will just directly use the built-in function in Excel. Since this is sample data, so we usually calculate use this one, the variance sample. Variance sample, and then we will select this area. This is the open number. So we got their variance for the pilot and co-pilot. Since we got those numbers, we can substitute those numbers into the this independent t-test, the formula for this one, the z number. So z is equal to, so we will substitute this equation. X1 minus X2 divided by variance 1 divided by N1. Oh, I forgot to take the N1 is 40, no, N1 is 38, right? Number N1 is 38 plus the N2 divided by number of N2 is 42. 42, right? And then we will take the square root. The square root will be 0.5, right? So we should be correct. So we got the z number is minus 2.03. So we got the, and then based on the normal distribution table, we know this is a reject region. This is a reject region. Approximately 1.69. Right now, our sampling z value is here. It's minus 2.03, right? Okay. Approximately minus 2.3. So this is in the reject area. So we will reject this hypothesis. This means the pilot. It means the pilot and the co-pilot, their respect to the service level, they got the significance. So it means they have significance difference regarding to the service level of the ATC. And who is the best? Who consider is better? The co-pilot consider is better, but the pilot consider is worse. Okay. So that's the independent t-test. And this kind of test can be applied in many situations. For example, we might consider, just as I mentioned, you might consider, okay, if you want to test if the boy and the girl, their mathematical ability has a significance, or the boy and girl, if their language ability has the significance. Or we can consider if the north of Taiwan and the south of Taiwan, the labor, the average salary has a significant difference. So those are very typical situation. We can use this independent t-test to test if the two different groups, they respect to some response, if they have a significant difference. So our hypothesis is assumed the mu1 is equal to mu2, and then we sample in some data, and then based on this, based on this observation of this data sampling, we can calculate their z number using this equation, and then based on this z number, we will consider if they are in a reject region, and then we will say, okay, that's the has the significance or not. Okay, so that's the independent t-test. Any question regarding to the independent t-test? Okay, if no question, we'll move to another one. Another one is called the pairwise t-test. The difference between the pairwise t-test is in the independent t-test, for each sample, there are different. For this one is one people, this is another people, this is another people. But for this one, S1 is maybe one boy, this is another girl, this is another boy, this is another girl. But so that's the X and the Y may not be the same, just like this is a pilot and this is a co-pilot. So this is two different group of the people, or different group of the sampling data. But for the pairwise t-test, this is the same objective. We give them two different treatment. This is treatment 1, they got this response. And then we got another treatment 2, they got another response. And then we want to test if this kind of treatment, they have a sequence or not. Okay, so this is the pairwise t-test. The example of this kind of test may be, some medicine. If you add some medicine, or you invent some medicine, you ask them to test. Okay, this is maybe some kind of the drug. Okay, if or medicine, they can. We want to test if they have a significant effect to reduce your blood pressure, right? So this is before you take the medicine, your blood pressure may be 140, and then after you take the medicine, maybe your blood pressure drop to the 120, and then for the second patient, before the medicine, maybe he is the 145, and then after the medicine, he might become the 142, and then the third patient, maybe give this medicine before the medicine, after the medicine. Okay, so that's the typical. So for each data, it's a pairwise. So N1 and N2 should be the same, of course, because the same people or same objective, you give them two different treatment. Okay, so another example is maybe you can go to the cram school, 补习班, and then this is the before you go to the cram school, your mathematical test or your TOEFL test, whatever, is this number, maybe 82. And after go to a bushiban or cram school, maybe you improve to 95 or 98, whatever. Okay, there's another case. You want to test if this cram school, they really improve the students' score. So that is the pairwise t-test. So there's a different with respect to another one. And same as the previous one. So in this way, we will assume the different mu naught is equal to mu d naught. It means this can be 10 point or 10 whatever. Maybe you will say, okay, after after you come to our cram school or come to our bushiban, your grade will be, or your some kind of test or college entrance examination will improve at least 100 points. So this may be 100 points. Okay, or you can say, okay, you will have a significant improvement. So this will be the 0, right? Just same as the previous independent t-test. So this can be any number. For most cases, is we want to test if they have symptoms. So it's 0. But you can also test. Okay, you come to our bushiban, or if some bushiban say, okay, their teacher are very excellent, and then you go to our cram school. Then the next year, when you take the college entrance examination, your score will improve at least 100 points. So this will be the 100 point. Okay. So that's you can set any number here. And here, then we will define that d is equal to x1 minus y1. d2 is x2 minus y2. This means the difference between two different treatments for each objective, right? And then we will calculate the average. This is average of the d. This is the variance of the d. And then we will check this number. If they have the they are in the reject area. If they are in the reject area, then we will say we shall reject this hypothesis. Okay. 它这跟那个前面不一样，就是它这个样本它是成对样本，所以成对样本就是说每一笔资料都是同一个人或同个物件去做的测试，那只是有两种不一样的处理方式。第一种处理方式，它的结果是这样；第二种处理方式，它的结果是这样。好，那我们要看说，那这样子这个是不是有显著的改善，或显著的不一样？我刚才举了两个例子，就是一个是药假设我们要这个你要发明某一种药降血压药那这是吃这个药之前的血压多少？吃药之后，它血压是不是有明显的降低？可能你测试的15个病人然后去测试说这个药是不是真有效或者是补习班，我刚才讲过补习班，那你也许补习之前第一年考试是学测几分结果我们补习班之后，第二年学测就变几分假设某个补习班宣称他们的来我们补习班可以至少增加100积分，100分就是学测成绩总分会增加100分。那我们的这个 hypothesis 就是说，至少这个要100，就是这个至少要差距要100分以上。那但是大部分我们都是说有差距就可以，不需要有进步就好了，不要求一定要进步100分。当然你也可以测试说100分我测试说，我这补习前跟补习后至少成绩会差100分。那或者是说，那这边是0号，就代表说补习前跟补习后至少有进步，进步1分2分也算进步，只要有不一样就叫进步。OK， 所以这个基本上跟 刚才的 independent t-test 不一样的地方。Okay, so this is the basic concept. Because some students, sometimes you confuse when do you need to use the independent t-test, when are you need to use the pairwise t-test. The pairwise t-test means for each object or each sample, this is the same people or same object. But independent, for each one, they are the different people or different objects. Right. Okay. So this one, we will see. Okay, this is a pairwise t-test. So, for example, we collect 15 patients. This means the patient number 1, patient number 2, patient number 3, and then we want to test if some kind of medicine, if they really can help the patient reduce their blood pressure. Okay, we give them a test. So before the medicine, we measure his blood pressure is 70. After we found his blood pressure reduced to 68. And the second patient, the original, is 80. And then after the medicine, it became 72, and so on. Okay. So this is X, this is Y, just like here. This is X. Here's Y. So we need to calculate the difference first, right? So the D would be this one minus okay, and then we will, I forgot the formula. So the formula is here, right? So we usually say this is equal to 0 because we just want to tell if they have a symptom effect. We do not want to test if this medicine will decrease at least 5 degree or whatever. Okay, so we want the average. Average, okay, the average here will be average. This is the average, and also we need their standard deviation, okay. Standard deviation. It's also very easy. This is the standard deviation, right? This is standard deviation for the sample data. Since we only sampling 15 patients. got the average is 8.8. The standard deviation is 10.97. Okay, then we can substitute this equation. So it will be equal to T equal to, substitute this equation. Average, right? Average divided by standard deviation divided by n. N is 15. So we got that T is 3.105. So since this is the small sample, but actually you can use the Z normal distribution, but since this is the small sample, so we need to check the T value. So you can go to the show you the probability distribution. You can use find the t-test, and then the V is the degree of freedom. The degree of freedom should be 14 because the degree of freedom in the t-test is the n-1. Right now our n is 15, so it should be 14. And so we got if we use the two-tail hypothesis, we will got the number is 2.14 approximately. Okay, if you input the V to the 14 and the probability, you input the 0.025, then it will give you the 2.14, right? Oh, I was wrong. Sorry. It should be the two-tail hypothesis. It should be okay. 2.5。Because we are the two-tail test. So I'm sorry. It should be. Uh, 2.5. It should be 2.5. I put it in a line group, so you can check the line group. So the V you give it 14, and the P you give is 0.025. Okay, here it's 0.0 because this is two tail. So you put the 0.025, and then it will give you the approximate 2.5. And then actually we can use the, let me see, you can use the data, and then there's a data analysis here. Did you have the data analysis here? If you use the data here, and then it will give a data analysis here. In the data analysis, they have the t-test, pairwise t-test. This one is pairwise t-test. You can select this one, pairwise t-test, and then the variable number 1. This is variable number 1. The variable number 2. Oh. You got the T number is the same, but his critical value is he used this one, 2.14. That'll be real. We use the 2.14. Anyway, the p value is here. Another way is we can make a judgment from the p value here. This p value is the 0.0077. It means if this hypothesis is correct, if that hypothesis is correct, then this observation, the chance of the probability, this observation, the probability only 0.0077. So it's very, very small. It's almost impossible to happen. So it means the original hypothesis is wrong. So we should reject the original hypothesis. 哦，这边有点怪怪，为什么它这边是2.14变成我们跟我们那个第一次查的是一样？Anyway， 但是我们看这个 p 值的话。因为 p 值很小 ，because the p value is less than 0.05， 所以会发生这种情形的机会呢，只有只有0.007，大概8%左右，8%左右，所以是已经远低于远低于5%了嘛，所以代表说这种情形，如果它的虚拟假设是正确的话。会发生这种目前我们看到这个状况的机会呢，只有0.007，
是很低很低的，所以代表说什么？几乎不可能发生嘛，几乎不可能发生，代表说我们的原来的虚无假设是错误的，也就是说，这个药呢，我们虚无假设是说药是没有差别嘛，就是它没有差别，就是零嘛，就是说它前后吃药前后它的作用是一样，但是我们现在发现它的这种，如果那个虚无假设是正确的话，会发生这种机会的几率只有0.007。所以几乎是不可能发生的，所以我们就是拒绝我们的虚无假设，也就是说，这个药确实是有效的，它能够有效的降低血压，这样子。OK，let's take a break. 如果各位电脑没有这个分析资料分析这个选项的话，你们可以到档案其他选项，选争议集，争议集里面有一个分析工具箱 ，Analysis Toolbox，Open this one, go, and then click all of them, and then sure. Then it will pop out. 如果你们的电脑没有这个，没有这个啦，因为我们这个会用到，这个是另外的先行规划的问题。所以如果你的电脑你选资料找不到这个的话，你要去争议集里面把那个工具箱打开。我们休息一下。去西派借一下，要没有电池啊？没有电池。就说现在，现在是里面会是什么？反正它以后我们至少。所以会还是要注册嘛？Chris, because the conference, if you submit your content, then you need to be short. So the conference will not very good.
Is that new policy? Copyright? Is that new policy?
No, this is most of the IEEE conference they will ask you to sign a copyright. So I do not like to attend the conference IEEE. They usually are more expensive and also they usually need transfer of copyright. As long as you copy the copyright, then that paper will be useless.
电是相当位，可是其实我们应该是做双位，因为我们只是要看它有没有差。可是我不晓得为什么它是这个 Excel， 它会变成一个单位的数，应该照理说应该是。对啊，所以我一直觉得有怪。对，怎么说啊？它是2P 啊，它不是 P 啊，2P 没错，它打0.1啊，我刚打错了，所以这边对，没有错，它也是有对。2.1是对的，因为它是2P 啊，我刚刚没仔细看，它是2P， 所以你还是要，它是两边累积加起来0.5，所以你是要打0.5，不是0.02。所以它是2P 的，它是2P 的，对，打0.5，所以应该2.1。打错，sorry，那是 SD。OK， 谢谢。对不起，这边这个打错，这应该是 SD 啊，不是 SD， 这边是 SD。给这里，这应该是 SD， 代表是它差的那个差值的标准差。
那意思就是这个 SD 要把它看成
没有啊，这个
那这个
这是变异数啊，这边是标准差，变异数，但它差的比较少。
传是一些